It's not too long, okay? Very simple thing. Basically, you need to understand in general. So that will be telling you the basic for the computer we're using right now. Inside, they get the microprocessor. You understand now the computer with the CPU. The good right now will be i7, okay? i5, i4, i3. That's why when you buy the computer, you have to let them know which one you want, okay? And this is the control everything in your computer. And the next one, they're talking about the random access memory. That's the memory. That's what we're learning today. Okay. The next one will be ROM in basically read only memory. And the last one, IO, input output device. See how they connected. You see address bus for the computer now. How many wire on address bus? Whoever knows, let me know. How many wire?
$32 or 64.
64, right?
Yeah, right now it's 64.
Yeah, normally i7, 64 wire. Okay. How many data wire?
The same, 64.
No, 32.
Because
And yeah,
controller of the data. Okay. 32 and 32. Yeah.
yeah, and a control bus. That means the CPU need to know, okay, what to do. And now we're talking about address bus only coming out from the CPU. Okay, that means CPU want to talk to the memory RAM or ROM or input output device. Okay, so you can select either one. So you see the arrow, they just coming out and coming in here. Okay, and the data bus, you say bidirectional. That means data can coming out or data can coming in. Okay. Next will be control bus. Same thing, bidirectional. Data can coming out or data can coming in. I given you the example. When you try to print something, okay, then here input output interface, they connect to the printer. Okay, so if you want to print something and the CPU will be send the signal, to the printer, asking for printing. Okay, then the printer will have to be returned to the CPU to let the CPU know, are you ready or not or whatever. Okay, that will be go to the control. But if the printer okay, then that's why they can print. Okay, if the printer get a problem and the CPU waiting for your signal coming in for a certain time, if it's not, and they will let you know your printer get a problem. Okay, and the next RAM, memory, access, random access memory. That's why when you go to buy the computer, they will be asking you how much memory you want. Now you can see you can want 4 gigabyte or 8 gigabyte memory. Okay, and basically this is the one working during the time. Okay, you working on your computer. I can tell you, first thing, when you just turn on your computer, then the RAM memory here will be empty. Okay? And when you turn it on, your computer will be go into the loading on of the data need to running your computer, loading into the RAM. Like, you get a Windows 10, you get whatever, they will be loading into this memory. A bigger memory will be better. Okay? Remember, when you turn off your computer, this RAM here will be erase everything. Next one, ROM. In the past, they call read only memory. That means the data coming out the ROM will help the computer to running. And this data cannot be erased no matter what. And later on, you can see, you can get the EEPROM, EEPROM, or so far. Okay? That is a general computer idea. Now, memory concept, data stored in the memory by process called writing and are retrieved from the memory by process we call reading. So basically on the memory, you get only two process. You try to write data to the memory, or you want to get data from memory. So that means you get a writing data or reading data. Okay, now I get the question. You know, when you say internal, I, what is I? If we're talking about the software, what is I? You have to tell me, what is I? You see how much you understand.
Yeah, it's an input.
When you're reading, they say integer 8. My question is, what is 8? Basically, on the software,
It's a variable.
what we call variable. Correct?
Yep.
Okay. That is basically on the software. Now, try to understand a little more. In the hardware, what is 8?
The input.
No. Okay, now, if we're talking about a hardware, there will be a location
Oh, yeah, memory location. Yeah.
in memory. Or we say that will be address. Now, try to understand in the computer. Now I get the computer only 3 wire. Address. Okay, what I said, C, B, A. If you understand that one, you can understand the computer we're using right now, not 3, 64. Okay, I'm using the small one in order to help you to understand. If I get only 3 wire, 3 variable, CBA, how many combinations?
8.
8. First thing you can say, 0, 0, 0, 0, 1, The next one, choose 0. Choose 1. Zero, 1. So that one show you address 0. And the next one, 1. And the last one, 7. Okay? When you say X is a variable, the thing is what happened inside the computer. Computer understand only one thing, binary, nothing else. Okay? However, we are human. We cannot directly understand a binary. So that's why we're using the alphabet, numerical also. That's okay, but I can be any location in the computer. Okay? So basically, that's just a location, just an address. So if you say X variable later on, you can say X equal 15. That means I can give you example. Example, this is the X here. So they contain the number 15. Okay? So basically, just a location. Okay? So you can get the write data. That means you write data into the location X. And if you're reading data from location X, you can get number 15. Memory are made up of stored location, which data can be stored. Each location is identified by address. The total number of bits that a memory can store is its capacity. Okay? When they're talking about capacity, okay? That means telling you the total, how many bits. And also now, to get along with when they say 1 byte, you have to know equivalent to 8 bit. Okay? Memory are made up of stored elements. Either they're using the flip-flop or the capacitor or magnetic, okay? You already know the flip-flop. Flip-flop, that means device get only one output. For example, D flip-flop, okay? You get only output Q. And another one not Q, not using, okay? Normally, flip-flop only one output. Okay. Or they say they can using capacitor to be memory. And you understand capacitor. When they charge full charge, 5 volt, logic 1. They discharge to 0, then they will be logic 0. Okay, that's only thing we need to talk. A storage element equal a cell. Okay, now you see that one. This is the memory with the 4 wire. So that means you can get from 0 to 15. Okay, this is address 0, and this is, last one will be address 15. Okay, when you want to writing the data 1001 to this location. Okay, now after you writing, data will be 1001. That's what we're talking about. Process to writing the data to the memory. And this one will be a reading. That means you want to go into location 1 to get the data. That's what you call read. Okay? When you reading, they coming out will be 1010. Now you understand what the process for writing the data or reading the data. Another thing you need to know, if I scan the data 101 to a data 1010, okay. So if I change to 1010, what happened is at the location 1, they erase everything and they writing data, new data to that location. However, if you're reading the data from location 1, data coming out. However, in the location data still there. They not erase it. Okay? That's the difference between writing and reading. Okay? If you get anything confusing, just bring it up. Okay? Okay, semiconductor memory basic. Memory is portion of a computer or other system that store binary data. In a computer, memory access millions of times per second. So the requirement for speed and accuracy is paramount. Very fast semiconductor memory is available today in modules with several gigabytes okay, 1 billion byte of capacity. Unit of binary data, bit, byte, 8-bit, nibble, 4-bit, and a word. At the roots, memory store data in units that have from 1 to 8-bit. The smallest unit of binary data, as you know, that is a bit. That means the smallest. In many applications, data are handled in 8-bit. That's what we call a byte. Make sure you know when we're talking about 1 byte, that means 8-bit. The byte can be split into 2 4-bit. That's what they call a nibble. Nibble, only 4-bit. Byte can also be grouped into words. The term word can have 2 meanings in computer terminology. In memory, it is defined as a group of bits or bytes that act as single entity that can be stored in one memory location. In assembly language, a word is specially defined as 2 bytes. Basically, this is a very, very basic, and you have to keep reading over and over, okay, in order to understand what is a word. A word specially defined as 2 bytes. Basic memory array. Each stored element in memory can retain either 1 or 0 and equal a cell. Memory are made up of arrays of cells, okay, using 64 cells to be identified by specifying row and a column. That's what we already telling you. How many rows, how many columns. 64 cell array can be organized in several ways based on unit of data. Okay, if you're looking at this figure here, 8 by 8 array, which can be viewed as either 64-bit memory or 8-byte memory. Part B, so 16 by 4 array, which is 16 nibble memory. Okay. Basically, a memory identified by number of words. It can store time, the word size. For example, 16K by 8 memory can store 16,384 words of 8-bit memory. Now, you need to know K. K in the memory equal what? They not equal 1,000. K in memory equal 1,024 words. That's a very, very basic at the beginning. Okay? Otherwise, later on, you get lost. Okay? Actual number of words only of power of 2, which in this case is 2 to power of 14 equals 16,000. 384. However, it's common practice to state the number to the nearest thousand. Okay, in this case, they're using 16K. Okay, and 16K 1024 words given you the total. How many words? That's what they already talking about. Okay, if you try to read it, you can see that. Memory address and capacity. A representation of a small 8 by 8 memory chip is shown in figure 11.2. 11. Let's see. Okay, we'll see that later. Location of the unit of data in the memory array equal address. That means the location or address same thing. For example, in port B, the address of a bit in the two-dimension array is specified by row and column. Okay, part C, address of a byte is specified only by row. So, as you can see, the address depends on how the memory organized into units of data. Personally, computers have a random access more organized in bytes. This means that the small group of bits can be addressed as. Okay, so this one you can read it. Okay, too much detail, and really we don't care much about that. That's how, the memory location. Basic memory operation. Address is the process of accessing a specified location in memory. Since a memory store binary data, data must be put into the memory and data must be, copied from the memory when needed. The write operation put data into specified address in the memory, and the read operation copy data out of specified address in the memory. So basically, they just telling you how write operation and read operation. Okay. This is a process, you see that? This is the memory. Okay. And if you want any data from any location, you have to let them know what address. Okay. And this is the data. And you write. Data will be writing to that location. Read operation. Okay. That means for the read operation, same thing. Okay. You must tell which location you want to get data. Okay. So you say, I want location number 3. And now the data sent to the memory will be read, and the data from this location coming out. That's a very simple. Okay. Type of conductor memory, ROM, read-only memory, non-volatile. Data can be read, not write. RAM, random access memory, both read and write operation, and wrote title memory. So data are lost if the power is removed. So now you understand. ROM, you turn off power. Data cannot be erased. However, RAM, when you turn off your computer, everything will be clear. Okay, ROM in the past. Okay, now in the up to date, they're using PROM, programmable, read only memory. Data are electrically stored by the user with the aid of specialized equipment. EEPROM, electrical program able ROM, electrically programmable by the user and can be erased either by exposure to ultraviolet light or electrical mist. EEPROM, okay, electrical erasable. Now, in the past, if you want to do changing something in your computer, I given you example. Normally you're using the black display, and now you want to update it into the color display. What happened? You have to open your computer and set the switch inside the computer. That will be changed. Okay? So basically, at the beginning, really tough. The thing that nobody wants to open the computer. Okay? So that's why they coming out with a different PROM, EEPROM, EEPROM. Now, if you want to change something in your computer, when you turn it on, you press F2 or DEL. They take you into the setup system. Then you can check. Okay? You don't have to open your computer. That's what they're using. EEPROM. Word and byte. A complete unit of binary information or data equal one word. 8-bit group equal a byte. Capacity or way of specify how many bits can be stored in a particular memory device. 1K represent 1024 words. Example, a certain semiconductor memory chip is specified 2K by 8. Okay, how many words can be stored on this chip? How many total bits can this chip store? Now, you answer for me. How many words? Who can tell me how many words? Okay, 1K, 10, 24 word. 2K times 2, 2000,
2000
48, right?
plus 8.
That is the first question. How many words? The answer will be 2048 words. The next one, how many bits? That means you have to multiply by 8. That telling you total number of bits. Address, a number that identify the location of memory of a word in memory. That means basic definition, address, read operation. A binary word stored in a specific memory location, that means address, is sent and where then transferred to another location. That means read operation. Write operation. A new word is placed into particular memory location. It is also referred to store operation. Okay, another one. Access time, amount of time required to perform read. Cycle time, amount of time required for a memory to perform a read or write operation, then return to its original state ready for the next command. That's what they call it. Cycle time. A certain memory has the capacity of 4K by 8. How many data input output line does it have? Okay, now you can say 4K, 1K will be 1024 times by 4. And 8 here will be 8 bit wire. So basically, this is 2K or 4K by 8. They can get how many wire, address, how many wire for the data. Okay, how many data input, output line. Okay, does it have? How many address line? What is capacity in byte? I try to say, okay, nothing at all. Now, first thing, 2K, now 4K. 4 times. Okay. So that will be given to you, the total. Okay. Capacity. And it will be 8 bit. Okay. That means you can see in here somehow. See, 1, 2, 3, 4, 5, 6, 7, 8 bit. You see that? And they can go up to 4K. Okay, 40, 96 location. Okay, and the data will be 8-bit, and you can see they can get 1, 2, 3, 4, 5, 6, 7, 8-bit. How many address lines, okay, does it have? How many data? Okay, you know that it will be 8-bit, so they will be got 8-bit of data. Okay, now pick up a one simple 2K by 8 by 60. Okay, so if 2K memory 2K by 16, okay, so how many data line?
$32K.
Okay, how many data line? How many? Here,
16, yeah.
60. Okay, how many address line? Okay, try to say 2 power of 10 equal what? Two times two times two times two, right?
Yep.
1024. Okay, so basically, this memory, okay, will be get 10 wire for address, 8 wire for the data. Okay, and when we coming back, we can get a second one, a little more detail. Okay, for your guy about the memory. Okay, now I want to tell you a few things. Okay, Okay, now you see that is the memory. Okay, and you will be get the lab with that kind of memory. Okay, if you're looking on this IC, the part number will be 6116 memory. And if you're looking into in that one, okay, just telling me how many wire thread. Okay, let's see. I see. 61. Okay, 16 memory. Okay, a thread. How many a thread? If you're looking that, you can go from A0 to A10. Is it 11?
11.
Okay, 11 line. Now, if 2 power 11, can they 48 watt? Okay, two power 11 equal to 0, 48. Okay, that means they get a total 2048 watt. However, in the lab, we using only 8. Okay, we don't want too many watt. That just take longer, but the way will be the same. So that will be number 1. Okay, and number 2, data line. You already know that will be 8. If you're looking into here, data D0 to D7. Okay, now what else? Pin 21. Right. operation. What's active?
What
That means
here?
0.
0. That means you see the bar over, right? Active low. What that mean? Low you run to right. Okay? And normally one will be reading. Okay? Right operation. Active low. Okay? If high, then read. Okay? Operation. Okay, so basically you want to write data into the memory. Then pin 21 must be low. And if you want to reading data from the memory, pin 21 must be high. Okay. Now, next one will be pin 20. Right will be pin 21. The next line will be pin 20. Okay. I can tell you. Output. Okay. Enable. Now, that means pin 20 equal 0. Allow. Output coming out. Normal. Pin 20 equal 1 for writing. Data to memory. Last one. Pin 18. Enable memory. Okay. If pin 18 equal 1, we can say 1/2. No. Graph or data can get into memory. That is the key point. If the pin 18 enable at logical 1, no address can get in, no data can get in, nothing. Okay, in here. So when you're looking into the schematic, you're able to know about the IC. Okay, let's see, for 6116 memory, you know that will be 2K by 8. Okay, you see, you know how many words. Okay, for address, how many lines for the data, which line for write data to the memory, which line reading, okay, data for the memory. Okay, so now finally I want to talking about to write. Okay, data to memory. First step, okay, see what we have to do. That means you want to apply the data into a thread, apply data to the data line. Okay, so to write data to the memory, first step you have to do, set enable. Okay, equal 1 to disable. Memory. Okay, that is the first thing we have to do. Okay, and now you can set a thread, apply a thread. Okay, A0 to whatever. Okay, number 3. Okay, apply pin 21. Okay, to 0. Right. Okay. Apply pin 20. Two, one. Okay. Do not read it. Okay. That means you apply a thread. And now write data. To read data. Okay. Same thing. Before you want to reading or writing. This line must be set to 1. Okay. And now number 2. Apply address. Number 3. Pin 21. Equal 1. That will be read. Okay. Number 4. Pin 20. Zero for read. Now, last one. 5. Okay. Apply. Pin 18. Zero. 2. 1. Okay. That means you want to reading, you apply a thread. Pin 21. Logic 1. Pin 20. 0. Okay. And pin 18 here will going from 1 to 0 to 1. Okay. Pin 18. Okay, equal 1, 0, 1. When the 0, that means data coming out. Okay. And they block everything. So any changing on the data address, they cannot go into that. That is how. Okay. So basically, you have to understand, okay, how to setting the memory. Okay, you want to write data to the memory, you have to apply data. Okay, pin 21 logic 0, pin 20 logic 1. Okay, and you want to write, then you apply address data, then apply pin 18 at the logic 1, go to 0, go back to 1. That means when they go to 0, they allow data here, go to that address here, and they block it. No more in and out until a new one. So if you understand, that will be helping you. If when they're not working, then you know how to troubleshoot it. Okay? Any question? Anything? I already telling you one thing. When you get any confusion, any problem with the test program, okay, anything else, you can text to me. I can on Zoom to telling you, okay, how to fix the problem. If you don't know what to do, don't waste the time, okay? Okay, any question? If it's not, okay, so we can stop at this point today. Okay, so you guys will be take care, okay? We-
I have one
Yeah.
question. So, since we don't have summer classes, right? We start classes back in the fall. Is that correct?
Yeah, if you get into the fall.
Okay. So,
in-
do you want to return the wire strippers and the IC chips?
The IC chip, that depending on, we can get the schematic for the lab or no. Okay,
You want us to return the ones that we have right now?
now the one you have right now is what lab? Up to the point, I know for sure, we get lab number 8,
Okay.
not 9 yet,
Okay.
okay?
Yeah.
Maybe you will be see lab number 9, okay? Anyway, you
Okay.
can working on software, okay?
Okay.
And you can contact me, okay? To ask any question, anything.
Okay. Thank you.
Yeah, no problem. Okay, so I wish all of you get a good holiday, okay? Long holiday. Even we don't want it, but that would happen. Okay? So take care. So good night, everyone.
Good night.
Good night.
Good night.